As you know, all the continents on Earth have different climates, ecosystems, and cultures. But it wasn't always like this. In fact, this will also change in the future. Someday, our world will change beyond recognition. All continents will become one great land. What will it look like? Well, I won't be around for this, but let's find out, shall we? Let's peek at the world map. There are 7 continents: North and South America, Africa, Australia, Antarctica, Europe, and Asia. If you know this, congrats! You still remember something from elementary school. Now, have you ever noticed that their borders line up quite well with each other? For example, South America and Africa look just like 2 puzzle pieces. The scientist Alfred Wegener also noticed this back in the 1910s. After finding this out, he continued to assemble the puzzle and noticed that India and Madagascar line up with Africa just as well. But that wasn't the only strange thing about the world. For example, we found the fossils of the same ancient animals on completely different continents. Now, how's that possible? They couldn't have originated as a species in Japan and Central America at the same time. That's just preposterous, a special word I like to deploy now and then. Could some of them have crossed the ocean? That's unlikely, unless they're some kind of Olympic swimmers. Maybe there used to be some kind of natural bridge between these continents. But even though so much time has passed, if it really existed, we would have found traces of this bridge. And what kind of crazy builder would build a road that long? There were a few other strange things. For example, people found traces of the same mountains both in the US and in Scandinavia. What does it all mean? Wegener thought hard about it, and then it dawned on him. A brilliant discovery. In 1912, he presented his idea to the world. The general idea was that the continents move like icebergs on water. They're constantly converging and diverging. Now, we know that he was 100% right, but unfortunately, scientists at that time basically pelted Wegener with tomatoes. He lacked data and couldn't explain exactly how these plates move. Nevertheless, Wegener didn't give up. He wrote a book called The Origin of Continents. And finally, in the 1930s, the geologist Arthur Holmes filled in the blanks in Wegener's theory. Finally, the world... we'll have to wait another couple of decades until the world realizes that this is true. People are kind of slow, huh? Anyway, now we call it the theory of continental drift. By the way, on a grammatical note, when we travel on a continent away from the beach to farther inland, we say we're going inland, rather than we're going incontinent. Big difference, don't mix them up. Meanwhile, the continents on Earth move along the mantle by several inches per year. Every few million years, they bump into each other and create the so-called supercontinents. Supercontinents are, as you might have guessed, huge land masses that consist of several smaller continents. We're still not sure how many of them existed before, but you've probably heard about one of them. It became the most famous because scientists believed that it was the only supercontinent in the history of the Earth. It was named Pangaea because Afro-Arctica-Euro-Aussie-Amerasia is too long to remember. Hey, just kidding. Pangaea from Greek means the entire Earth. Beautiful, right? This supercontinent existed for about 160 million years, but it broke up a very long time ago. That's why it's hard to even imagine what Pangaea looked like and how many things have changed on it. It was significantly different from our present Earth. For example, there weren't any mountain ranges that we have today. The CO2 concentration was 5 times higher than it is now, so the average temperature was much warmer. It's possible there wasn't even ice on Earth, only tropical forests. This Earth could be a greenhouse, and even the North Pole could be covered with rainforest. Sounds like a pleasant place. Dinosaurs witnessed all this, but we didn't. The first humans appeared only 2 million years ago, and the first Homo sapiens, which is basically us, appeared only 300,000 years ago. So, unfortunately, we as a species basically missed the cool continental drift part. But maybe one day, we'll be able to see what it could look like. You see, Pangaea wasn't actually the first supercontinent. There were at least 3 of them before it. The oldest one, Valbera, existed about 3.6 billion years ago. It became the grandma of all the continents we know today. Valbara included almost all of them. Then it broke up, like a couple on a bad date, and we got her grandkids, Ur, Kinnerland, Nuna, and so on. Eventually, it came to Pangaea. Now we know that they form every 600 million years. That's called the supercontinent cycle. That means one day on Earth, everything will merge together again. But when and how will it happen? Well, first of all, we need to clarify something. We have one supercontinent, right? Basically, one huge island. That means the rest of the world is now a superocean, except for a couple of small islands, maybe. The ocean at the time of Pangaea was called Panthalassa, and our cool, mysterious Pacific Ocean is actually just its pathetic remnants. The other two big oceans, the Atlantic and Indian ones, were born when Pangaea started to break into separate pieces. So when these oceans close, completely drying up, new supercontinents are formed. And every time they close gradually and very slowly. It means that the Pacific Ocean is shrinking in size right now. Yep, it loses a few inches a year. Boy, I could sure lose a few inches a year. Now, it's hard to imagine, but in the future, it will become an ordinary puddle. It will disappear together with the Arctic Ocean, and that's inevitable. But when it happens, a new supercontinent will appear, Amasia. The birth of Amasia was predicted by scientists from the University of New Curtin in Australia. They did some very complex calculations on a supercomputer. They uploaded the continental movements of the last 300 million years or so. And then, based on these calculations, the computer predicted what the future holds for us. We learned that one day, the Americas, both South and North, will collide with Asia. And this collision will create a new supercontinent with a very original name. As already mentioned, the Pacific Ocean will one day completely disappear. On the other hand, the Atlantic Ocean is growing right now, pushing both Americas to the west. So when Amasia appears, this ocean may become the new largest ocean in the world. So here's what it's going to look like. Both Americas will collide with East Asia, and although it's hard to predict, some sources claim that Antarctica eventually will find its way to South America. Australia will also play a huge role in this. It may connect America and Asia. So, it won't be down under anymore? Guess not. And if humanity somehow still exists, that means that you could hike from France to Australia or from South Africa to Argentina without getting your feet wet. So, here's a solution. If you can't travel right now, just wait 300 million years. And no, that doesn't count the wait time getting through airport security. Scientists also used to think that Amasia would gather around the North Pole, creating a huge ice cap and cooling the planet. However, now they think that this is very unlikely. It's probably going to be somewhere in the middle of the poles. However, this doesn't mean that the Earth will remain as friendly as it is right now. The Earth of the future will be radically different from what we know. The sea level will become lower, and the Amasia will consist of vast, very arid areas with high daily temperature ranges. Yep, it's going to be super hot. The ecosystem will completely change, but it's quite difficult to say what it will all lead to. The more data we receive over time, the more accurately we can predict the future of our planet. At the moment, all these are just theories, and scientists note they're still far from being proven. But even so, the results of the team's work are very impressive. They tell us a lot not only about the future of the planet, but also about its past. Wouldn't it be great if humans could live up to those times? We could watch from distant space how our home planet is changing. It's fascinating and a little bizarre at the same time.
Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylasolio. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritius broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future. These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for two reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it, the Ansilonema alaskana and the Ansilonema nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile deep ice core extracted from the center of Greenland. They found that the soil had traces of willow wood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it.
Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that sea is what scientists call the supercontinent Pangaea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangaea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangaea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangaea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system. Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other landmasses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The Lost Continents landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritius. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Sahul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Sahul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that.
If you've ever driven over the Rocky Mountains, you've probably seen road signs for the Continental Divide, the backbone of North America. All watersheds to the west of it run into the Pacific Ocean, and everything on its eastern slope goes straight into the Atlantic. There's just one creek in Wyoming that couldn't choose one side and drains into both oceans at the same time. Two Ocean Creek begins its journey high up in the Teton Range. The snow-capped peaks provide the perfect backdrop as the creek starts its descent, winding its way through alpine meadows and dense forests. As the creek continues its course, it gets to the Two Ocean Pass. This is the geographical crossroads where the creek splits into two branches, the Atlantic Creek and Pacific Creek. The Pacific Creek goes westward and becomes part of the larger Snake River watershed, bringing its waters to the Snake River, which eventually merges with the Columbia River and, finally, reaches the Pacific Ocean. The Atlantic Creek heads eastward and flows into the Yellowstone, Missouri, and Mississippi rivers and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers struggling to find the Northwest Passage between the two oceans never knew they could have used the creek. They would just have to use really tiny boats. Some scientists believe that cutthroat trout had better luck in that way. They managed to migrate from the Snake River to Yellowstone River, most likely using the Two Ocean Creek. Technically, fish can travel over 6,000 miles to cover the whole distance from sea to shining sea in fresh water. The creek could be just perfect for that journey. There are hiking trails in Grand Teton National Park that lead to Two Ocean Pass. If you feel adventurous enough, you can stand at the literal crossroads of the continent and see the beginning of two aquatic journeys. Lonar Lake in India popped up literally out of nowhere around 52,000 years ago. Newer data says it could be much older, probably over 500,000 years. At first, scientists were sure that the lake was in an ancient crater of a long-extinct volcano. But then, geologists made a detailed analysis of the soil and water and found out that Lonar Lake has a space origin. The minerals found in its soil are similar to those found in moon rocks brought to Earth during the Apollo program. The lake is an impact crater left by a huge meteorite, which was almost 6 times heavier than the Empire State Building. The impact was so strong that the volcanic rock melted and turned into glass. In 2020, the lake, which was already unusual enough, suddenly turned pink. It wasn't a part of an early Barbie movie marketing campaign. The detailed analysis showed that the water contained an increased level of unique microbes. They accumulate on the surface and emit some pink pigment. After a while, the microbes settled to the bottom and the lake became transparent again. Flamingos that got their food from the lake also got to taste some of the microbes and became an even brighter shade of pink than usual. One of the most famous sights of Yellowstone National Park is the Grand Prismatic Spring. It's one of the largest springs in the world, and it's inspired people who have seen it since at least the 19th century. Back then, a group of trappers mentioned an indigo blue lake boiling like a huge cauldron. Decades later, expeditions came to the spring to study it better and explain its unusual appearance. But because the spring at its widest point is longer than an American football field, they had to build a special vessel and travel far from the shore. The scientists traveling in the boat never wore life vests. They knew those would be useless if the boat tipped over. The water in the middle of the spring is of near boiling temperature, and those vibrant colors are the result of extreme organisms living in the hot water. The temperature changes as you travel away from the center. Different species that don't mind the heat have settled in different parts of the pool, giving it its famous diverse pigments. Back in the early 20th century, someone got the interesting idea to try to irrigate a part of Nevada's Black Rock Desert. They drilled a well and found lots of water, but it was near boiling temperature. The water was clearly not good for agriculture, so the human-made geyser was left abandoned. Over the decades, it slowly turned into an impressive cone of calcium carbonate deposits. Then, in 1964, a geothermal energy company drilled another well close to the first one. The water they had found was of the same temperature. This time, it wasn't hot enough for their needs to produce energy, so they decided to cap the well and leave. But water managed to get up and out, and it completely dried up the first geyser. The second one, which got the name Fly Geyser, is still flowing burning hot water rich in minerals. The cone is multicolored and looks like it's not from this planet, thanks to the algae living in it, which love the heat. Every summer, Caño Cristales in Colombia turns into a liquid rainbow, or the River of Five Colors. At this time, and until the end of fall, the conditions are just right for the riverbed to turn bright red, yellow, green, blue, and black. We owe this beauty to certain aquatic plants growing in the river, a special type of riverweed. During the wet season, the river moves fast and the sun cannot get to these plants. During the dry season, there isn't enough water to feed them, so the time in between the seasons has the perfect conditions for this colorful show. It doesn't happen anywhere else in the world. At some point, the number of tourists who wanted to see it became so huge that scientists got concerned it could be bad for this hotspot of biodiversity. The area is home to rare species of animals, birds, and plants. Now, there are ecotourism trails and strict opening hours. In August 2014, a man in Tunisia was going back home from the north after doing his business. It was a hot summer evening and he was dreaming about water when suddenly, it popped up right in front of him. There was a whole lake in the middle of the desert, and the man was pretty sure it hadn't been there several days before. The new body of water got the nickname Mysterious Lake, and actually became a great mystery. Hundreds of people came here to swim in the clear, cool water. The lake became a popular place, but a few days later, the water turned dark green. The locals didn't care about this and continued to bathe in the lake. But when scientists and geologists arrived at the place, they announced that the water was dangerous to swim in. The lake was stagnating. It didn't refresh itself from underground streams, and the rains didn't feed it either. That's why the water became moldy and dirty. The lake contained algae and a lot of harmful bacteria dangerous to the human body. Scientists also found out that the land in this region had phosphate deposits. This substance can decay. But even that didn't stop people from bathing in the lake in the middle of the desert. How it got there remains a mystery. Some experts think that heavy rains have filled a hole in the ground with water. Another, more popular theory says that an earthquake had formed the lake. The seismic activity must have torn the Earth's crust above the water table, and then underground springs had filled the crevice. So, in theory, the lake could drain back out one day, just as suddenly as it had appeared.